Right. Good afternoon. We have discussed the time series data analysis and how to analyze the time series data. Uh, so then, rather than that discussing the theoretical rationale of the unit root testing and the unit root test and the co-integration. So then I use that real data set and then to analyze how to analyze the time series data series. So then that in the finance central bank or the finance researchers, scholars have to understand and forecast the macroeconomic time series. A serious problem, the major problem they face is that those series are often trended and affected by persistent shocks to the process. To try to get to minimize this problem, or at least to understand its possible effects, it is common to test whether series are stationary. These tests are often called unit root test. Right, today we have discussed this unit root testing. Right, what is that called stationary? Stationary is very important for estimation. Applying just least square regression on non-stationary variables. So then assume that you have a time series data. You analyze by using normal least square regression model. So then if you do it, so then it can give misleading parameter estimates of that relationship between variables. Then checking for the stationarity can also be important for forecasting as well. So then it is very important to build a model to make accurate accurate predictions. Right, then the purpose of this topic, right, purpose of this subject as well, is to convey this message that unit root testing should be seen as a mandatory requirement that researcher need to carry out prior to the model building. But it is crucial to think about the dynamic properties of the variables and the data that measures them before the estimate and the forecast. The unit root is the one test to do that. It is very useful test for this situation. But there are alternative tests that might on occasion better suit for the model building trends. So then the bulk of that studies or the discussions consist of computer exercises intended to deepen the reader's understanding the issue with different unit root test and modeling on the non-stationary data. So then these exercises are written in eViews by using the econometric package, eView package. Most econometric packages have the necessary functions with relevant changes to command to read about the able to follow them. So then how to do the unit root testing. Right, so then there are no proof and little algebra, right? Because this lecture series, but this lecture, so then in that in theoretically, so then in textbooks and other that materials relating to the econometrics. So then lot of that proof and little algebra, many algebra. So then, but I'm teaching here this throughout the course by using that no proof and then with or no little algebra. Right, so then there are many textbooks to read to test the unit roots. Right, why we are that unit root, it is very important. Why unit root testing is very important. Right, it is common, that in macroeconomics variables or the finance variables to measure measure variables to increase or decrease, variables increase or decrease with time. Right, so then output, that output increases when as technology improves, output increase. The population grows and inventions occur, prices and the money stock increase as the central bank targets a positive rate of inflation and so on. Right, so then for example, so then higher the technological improvement, so then GDP is high. So then higher the inflation rate, so then it affect that monetary policy of the country. The monetary policy of the country impact to the private investment, and then inflation or the exchange rate, it impact for the share market, share prices, and so on. But these variables increase over time in the stock output ratio. Many economic theories posit there is a causal relationship between these series. An example close to many central bank heart, that the price level is a function of the money supply. The price level is the function of money supply. When that increase over time, variables that increase over time, the GDP data, so then we can see that it is increasing with the time. So then this is an example of the non-stationary variables. This non-stationary series may not increase over time. That it is not increase over time, but where the effect of shocks, innovations do not die out with time. Right, there are some effects. Right, there are some effects for these changes, but these changes do not die out with time. Right, that's why we call these are non-stationary. There is a major problem with regression that involved non-stationary time series variables, as the standard errors produced are very biased. The bias means whether there is a causal relationship between the variables are unreliable. Also, that too many significant relationship also found when none really exist. But in reality that is not, but there are relationships are significant. So then regression where this take place, but there is no such a relationship, but that you can see that in the results shows that there is a significant relationship between is found when the none really exist. The regression where this take place, normally we know it is spurious regression. So then many co-issue of the many central bank economists is to understand inflation and how it is history can be used to help the forecast the future inflation. The first step is to investigation is to think about the economics and institutionalized settings and so on. So then once the framework is chosen, it is important to investigate whether the data support your theoretical analysis. Right, so then in order to forecast, you need to obtain the coefficients of the model. So then to do this successfully, so then we need to confident the estimated method you choose and you choose a correct and right estimation technique. Right, what we call spurious regression. And econometricians generally wishes to test or quantify the causal relationship between variables, whether GDP impact to the investment, whether investment impact to the GDP. So then she has to infer this from noisy data with imperfect theory and statistical techniques. One thing they want to get to avoid the regression seem to give the good fit and predict statistically a significant relationship between these two variables, but these relationship in practice not exist. Right, so then this is known as the spurious regression results. Right, it is something like that. When you know that when there is a positive relationship, you know that it's a consumption and income. Right, when your results, if your data are non-stationary, when income increase, consumption goes down. So then that relationship is also significant. But the reason behind that is because you use the non-stationary data. Then the conclusion you made based on this is it's not really exist in practice. That's why we convert the data to stationary. Right, so then now there are 3 data files I have uploaded to the LMS. Go to, you know that it's a first data set. Right, go to the first data set. Right, this data set. This is, you know that you have 3 variables, x1, x2, x3, and then dependent variable is y. Right, so then what you need to do first is, first you know that go to the quick, right, estimate equation. Right, first you know you draw the graph. Right, quick graph. Right, so they give the, you know that name of the graph. All right, your variables are y, x1 and x2 and x3. So then these are the variables you have selected. Assume that these are the variables you have selected. You wanted to test whether uh, uh, are there any relationship between y and x1, whether there is a relationship between y and x2, whether there is a relationship between y and x3. Right, assume that those are your hypotheses, the relationship between y and x1, there is a relationship between y and x2, the relationship between y and x3. Right, so then first you need to see that whether these theories are stationary or non-stationary. Right, so then basic graph, you need to know that in the graph type, in the general, so then there are categorical graph and the basic graph. So then this is not the categorical data, it's a basic graph. So then specific graph types are mentioned, listed here. So then select its line graph because it is time series data. So here you need to select a single graph for each variables, or if you want to multiple graph for that single graph, all that variables are in a one graph, or multiple graph, so then separate graph for each variable. So then select the multiple graph and then click OK. Now you can see the graph, right? You can see these data are non-stationary. You can see the trends. So then you can see some, deviations here. In this here, that there is a deviation. So then here downturn. So then it's upward again downturn. So then those are the shocks, right? The shocks affect to the series, but these shocks do not uh, die out immediately. So then it lasted. So that's why we do we test the stationarity. Right, this is then these data are time series, and then we see that there are trends in these data. Right, so then I explain the previously. Right, variables, these that variables, here that x2, x3, y, x1, x2 and x3, these four variables, they increase, that increase and over time, change over time. So then that is, that increase over time. So then it is the one characteristics of the non-stationarity of the variables. Right, this series may not increase over time. Now it is, but that it is not increase over time because the effect of shock. So there's some shock effect because it may be that supply shock, it may be the demand shock. For example, that political impact as in election, right? It is a shock to the economy. That impact do not die out with time. Right, then these are non-stationary. Right, this is the major problem with regressions that involve non-stationary data. Right, as that standard errors produced are biased. So then this bias means that whether there is a causal, if you want to judge whether there is a causal relationship between the two variables, assume that y and x1 are unreliable. Right, too many cases, significant, then you can find there is assume that our actual real relationship, there is a positive relationship y and x1, but when you use that this data as it is, when the relationship between y and x1 is negative, Also you know that it is significant. So then that results will come because if you use non-stationary data uh, as it is and they use the OLS to analyze the data. Right now, now go to the quick and estimate equation. Now you know give the you know that date your equation is by you need to type the dependent variable first, then x1 the independent variables uh, respectively x3 y x1 x2 and x3. Right, so then click OK. Right, then this is the output you will get. Right, this is the output you will get. Right, assume that you assume there is a right, then you can see the one variable is insignificant and then this variable is also significant. Right, so then we use the stationary data as it is. So then we need to test whether the series are stationary or not. Right, so then there is another data file here, CPI and M1 and residuals, then everything. Write the same type of data. Right, then we have to here in this case we have three variables x1 x2 and x3. We have three variables. Then objective of collecting this data is to check whether there exists causality in variables. Right, you want to see the causality, whether there is a causality between variables. Right, so then for that, first test is we test the unit truth. Right, since the most of the variables or series in our variable x1 x2 x3 x1 x2 and x3 are non-stationary. Non-stationary because you can see the trends of all these series. So then unit truth is useful test to determine the order of integration. Right, order of integration, whether they are integrated in the first difference or second difference. Right, suppose two variables, assume that y and x2, y and x1, y and x1 had unit root at levels, but after first difference, they become stationary. So then that is, we call order of integration is 1. Right. There are different types of test. Right. There are different types of test. Right. There are different tests to test unit root. One is, most popular method is augmented Dickey-Fuller test. Augmented Dickey-Fuller test. Augmented Dickey-Fuller test is used to test the unit roots. Right, so then let's check the unit root in each variable. Right, go to the that file. Now go to the quick series, go to the quick and then series statistics, select series statistics and then go to the unit root test. Then select each variables separate before each variables, right? Y. Click OK. Right, then you can see the different test type here. Augmented Dickey-Fuller test. Right, there's a Dickey-Fuller, just Dickey-Fuller. Then Phillips parent test. Right, there are many tests. So then most widely used augmented Dickey-Fuller test and the Phillips parent test. Right, so then select augmented Dickey-Fuller. Right, so then it is that unit root first levels means data as it is. Right, if unit root test if you use the first check in the graph, you can't see. So if you cannot that determine accurately whether your data are stationary, right, then check when the levels data are stationary or not. Right, so then go to the test for unit root in the levels. Then that include the test equation here. It is intercept, 3 types of equation in the unit root. First, assume that there is an intercept. Then this is automatic selection lag length. So then select that this automatic one and now click OK. Right, so then here you can see the augmented Dickey-Fuller test is minus 3.6. Right, so then its a probability value is 0.01. That probability value is less than 5%. That means our series are stationary. Our series are in the first level, it is stationary. Now go to the again quick unit root test, and the y, go to that first difference. In the levels also it is stationary, and the first difference also it is stationary. Now that go to that next variable, series statistics, unit to test x1. Right, go to the levels first. In the levels you see that probability value is less than, it is greater than 5%. Probability value is 0.1745. It is greater than 5%. It is greater than 5%. That means our data are not stationary. Our data are non-stationary. Then that go to the same group statistics, unit root test y x1. It is first difference. Check the first difference. It is in the first difference. You can see that a probability value in this here, probability value is less than 5%. You can see this probability value is less than 5%. It means the unit root, the x1 has a unit root, null hypothesis. If it is unit root, it is a null hypothesis, we reject it. Right, that means it doesn't have unit root, that means the data series are stationary. Now the same process you need to do each variables. Unit root x2. First go to the levels, then click OK. So then in the x2 is also not stationary. It has a unit root in the levels. Then go to the unit roots, then go to the x2 first difference. You can see the first difference, x2 variables also stationary in this second difference variable. Second difference, it is stationary. Now go to our last variable, x3. First check the levels. It is non-stationary because it has a unit root, because the probability value is greater than 5%. Then it has a unit root. Then go to the levels. In the levels, as first difference, you can see it is probability value is less than 5%. That means the variable x3 has not unit root. It means the data in the second difference are stationary. Then x1, x2 and x3, all these three variables are stationary at the first difference, not levels. Then we need to consider the first difference variables for analyzing the data. So then we call it, our order of integration is I1, right? So then first difference becomes stationary, that is order of integration is 1. Right, so then this is the test in the co-integration, test in the unit roots. So then there is a data set here. In this data set, you can do the same. Right, you can do the same for the variables here. Here CPI, right, this is data set. This CPI, select, that check whether, first, that go to the right, first go to the graph, right, graphical view. First view the graph graphically, quick graph. Then need to give the all the variables, dependent variables and independent variable, list all the independent and dependent variables. Our dependent variables, treasury bills, CPI and money supply. It is multiple graph. Now you can see there is a trend here in the right, in this variable CPI. You can see the treasury bills, you can see the fluctuations, you can see the CPI in trend, money supply, you can see the trend, right? So then this data, right, this data, if you use this data as it is to analyze by using regression, and then your results will become nonsense. It is not realistic. So then let's that use this. First right, go to the quick and estimate equation as it is, treasury bills, CPI and M1. Now you can see that if we analyze the data, the CPI, right, inflation and treasury bills, it is a highly significant variable, and the money supply and the treasury bill, it is also the highly significant variable. Right, the reason is, but M1 money supply, higher the money supply, lower the treasury bills. Right, when higher the inflation, higher the treasury bills. right? So then those are, that not realistic for the uh, based on the theory. So then what you need to do is you need to check the all the data unit truth. So then one is, that treasury bills, right? See that treasury bill, that this is the graph, but test, let's do the test treasury bills levels. You can see this is treasury bills has a unit truth, but it is not a stationary at levels. Then what we do the second difference and the first difference, treasury bills, first difference, select first difference and click OK. Now you can see that in the second difference, so then these, that innovations, shocks, and then it remove, and then it remove the all the shocks and the innovations. So the second difference series are stationary. Do the same for all other variables. You need to test CPI levels. You can see it is the levels. You can see the trend right in the right, then you can view this right in the, this is CPI. You can see the trend, right? It shows, but in the it means the data are non-stationary. Now do unit truth first difference. Now you can see the first difference series are stationary. Here also first difference series are stationary. These variables of the first difference series are stationary. Now go to our last variable. Quick M1. Right, first go to the levels. It is also non-stationary because it you can see, that any fluctuations, you can see the trend. Right, you can see the trend. Right, in the CPI variables, you can see the augmented decay pool of M1. It is 1. You can see the, that trend. You can see that is trend. Then the augmented decay Fuller test shows that it has a trend. So then this trends, because this trend, because for the some reason, some innovation or the shock, right, that shock do not die out with time. That's what we do. So then that's why we need to die out these uh, shocks, impact of the shocks. Then do the same for the unit root for the first difference series. Then you can see in the first difference series are okay. Now all, that first difference series are non-stationary. Now now estimate equation, no, estimate graph D Y plus difference ne D treasury bills D CPI D M1. Multiple graph. Now you can see the difference between these two graphs. See the any difference between these two graphs? Where it goes? Graph at the treasury bills, the Y, the CPI, the M1, right? Multiple graph. Now you can see, compare, you know, that these two graphs. You can see that compare these two graphs. The first graph, data as it is, this is the graph. When we remove the innovation shocks, you know that this is the graph. When what we do is we consider the first difference variable, first difference of the series. Here we can see the upward trend, but if you remove that upward trend, then our series is non-stationary when the first difference. Money supply also the same. So then this data series can be used for forecasting as well as for the predictions as well as for interpretation. So then that's what we do under unit root testing. Now you can clearly see the difference between what's the behavior of the data as it is, that means non-stationary data, and what is the difference between stationary data. So then this is stationary data, this is non-stationary data. So then by viewing the graph, we can determine whether our series are stationary or not, but there is a formal test to do this. This test is called Dickey-Fuller test, augmented Dickey-Fuller test. So then augmented Dickey-Fuller test is used to test the unit root. So then hope this is very clear for you. So then with a small break, so then until then you test the unit roots for our next model, the next data series I have uploaded to this. Right. Then hope you have done. So then first, then again, that go to the our next data set. This data set. In this data set, uh, this is that actual data set. It is the your dependent variable is liquidity assets. Liquidity, capital adequacy ratio, CI, unemployment, interest rate, GDP, adequacy, right? So then check, that each variables. Quick, go to the graph. This adequacy, CA, capital adequacy and capital adequacy ratio, CI, FC, GDP, interest and unemployment. Right, those are the variables. Then draw the graph and see whether the series are non-stationary. Now you can see all the data, all the series are non-stationary. You can see the downward trend. So then this you can see the upward trend. Here this variables also the upward trend is a downward trend. So then this everything. So then when we win this data, you can see this data are not stationary. So then it is so then the serious problem here, the serious problem of the time series finance data the finance data is that they are often trended or affected by the persistent innovations. Innovations means shocks to the process. So then this sometimes that they are often trended or affected by the persistent innovation. right? To remove this problem, or to understand possible effect of this, it is common to test whether series are stationary. Right, these tests uh, are called right. So then in stationarity, is important for estimation. So then applying just regression OLS on non-stationary data can give misleading parameter of the relationship between variables. හදාගත්තා. අද ලැබුවා. Yes. And මං ඊට කලින් between variables, right, then check in for stationary. Stationarity can be important forecasting right. So then now what we need to do is do the first difference and then check. Most you know that all the time series data are unit root, or assume that it is separately these variables, or that is a graph, first graph in the second difference, right? The adequacy, that is the way we are writing. D means difference, CA means you know that your variable name. I can't remember the variable's name. Variables, yeah, these are the variables. I jot them down. It is variable name is AD, AQ, CA, capital adequacy ratio, CI, FC, GDP, and interest and unemployment. Those are the variables. Um, this is our graph. So then here, go to the again quick and then draw the graph for the first difference variables. D means first difference of the first variable. D, the variable name, and then D, capital adequacy ratio, and D, CI, FC, E, GDP, and the I, the unemployment. Let's see that graph, draw the multiple graph. Right now you can see the first difference. Is it first difference? You know that is the first difference. You know that's a that trend. You know that it's moving like this. This trend also, you know that it is like this, and then this. Okay, this one a bit okay. So then this one. Right. So then let's see that are there, you know, that any test. Let's do the test first, because in the graph we can't, you know, that actually see the uh, pattern. So then go to the, you know, that each variable adequacy AQ. Go to the levels plus difference. It is okay by the first uh, adequacy. It is okay. Then go to the next variable separately. Then go to the CA. Okay, for the first difference, it is also okay. This variable. Go to the next variable, series statistics and unit root, CAR. It is also okay, stationary. Then CI, it is also okay. Then go to the third variables, next variable unit root, for each variable separately. GDP is also okay. Then interest, it is also okay. Then go to the unemployment, it is also okay. So then all are non-station, all are stationary at order of integration 1. Right, then all series are stationary at level at first difference. Right now you can see these series are stationary at the first difference. Right, this is the way. If what you need to do is, what the lesson you learn from here, if you have a data set, right, if your data series are time series, if series are non-stationary, and then convert them to stationary by using uh, testing the unit root, and then this test we use the test is for the augmented decupular test. So then convert the data, otherwise you know that this is a serious problem. So then what I have written here, right here, what I have written here, here I mentioned that the serious problem of the finance data, they are often trended or they are affected by persistent innovation. But innovations are not persistent. You know that it is not persistent. Shocks are not persistent. It is, you know, that one time, but it, uh, it uh, do not die out uh, with the time. So then to remove the problem or to understand the possible effect of it, so then it is common, very common to test whether the series are um, stationary. These tests are called unit root. The stationary is important estimation for applying just OLS uh, on non-stationary variable can give misleading parameter of the relationship between the variables. Check-in for stationary, and important for check-in stationary is very important for predicting and as well as the forecasting. Uh, all series are stationary, and our one in this example for at first difference. Now in our model, so then let's see when we are using our data, uh, it is estimation equation, assume only the, you know, that capital adequacy ratio AQ is a function of CA, R, and GDP, I, and unemployment. Then this is the output. In the output, you can see most of the data are uh, not significant, but the unemployment, you know that it is unemployment data, it is uh, negative, expected effect should be negative, but you know that when higher the unemployment, right, it expected the theory says that there is a negative relationship between capital adequacy and the unemployment, but this result shows that there is a positive relationship, the positive relationship between unemployment and the adequacy ratio. So then if that is the reason behind that is if we use the non-stationary data, right, this non-stationary data, uh, right, this non-stationary data, we can see that they are, you know, that trended, some data are trended, and then some data are affected by the persistent innovations, but these innovations, these shocks innovations, impact of these do not die out with the time. So then that's why we will get the misleading results. That's why, you know, that is important for checking the non-stationary. So then if the checking the non-stationary of the data. Right, so then after doing this, after checking the stationarity by using unit roots, right, the test is, that Dickey Fuller test. After that, uh, right, so then this non-stationarity, right, this non-stationarity uh, non-stationarity series, non-stationary series in finance data, they may occur for various reasons, and the underlying reason have important implications for appropriate treatment for to the series. We need to give this good treatment for that. For example, assume that, for example, consider country whose monetary policy is a price level target, where when target increase uh, at a constant at a constant constant rate, that means in the absence of shocks, then inflation would be constant, right? When you know that due to some reason, so then inflation goes up, but in the absence of shocks, so then it is stable. Assuming monetary policy is effective although shocks will take place the price level away from target, right? That such deviations will be temporary, right? That temporary situation then the price level will not be stationary. In this case, right, then, but we can we will be able to extract a stationary series by detrending it. There is a trend, so then we need to detrend it. Such a series is called trend stationary. Right, so then it called trend stationary. So then there is difference in stationary as well. So then what we call difference stationary, right, it is difference stationary. It means that right, so then analysis is uh, relatively simple if economics data were only trend stationary. But another common situation is one where the series is subject to shocks whose effects do not die out, die away with time. For example, GDP. If you consider the variable GDP. Suppose GDP growth comes from purely because of inventions and gains in knowledge. Further, suppose that these innovations are not a function of time and that they are not forgotten. In each period, therefore, in each period, GDP equal to its previous period's value plus an increase to that period innovations. Right, so then in such a situation, we are able to make the series stationary by taking the first difference. But there are occasions where uh, where we may need to take the third, fourth difference of the series to make it stationary. We call these variables integration of order of integration in, the number of. So then these are the different stationarity. Right, that is very important. Some data, that different stationarity and trend in stationarity. So then it is incorrect identification. Right, so then incorrect identification of the type of non-stationary. Right, so then we know that is a first difference IO series, I1 series are stationary series, but differentiating between the two series is not easy. Right, if but no problem is that all series are stationary at the level, at the first difference it's okay, but uh, uh, if we mistakenly detrend difference stationary series or take first difference of a trend stationary series in our example. Our GDP is trend stationary or difference stationary. Right. If we detrend the difference stationary series, assume that GDP is difference stationary, right? If we mistakenly detrend difference stationary, so then what will happen? Then the effect, if we do this, if we detrend difference stationary series, the effect of errors will still be persistent. Right. So then this is, that is a problem for that. So then what is, that's the appropriate treatment of variables that appear to have unit root. right? It is, that we can answer what is the appropriate treatment statistically. What we can do, uh, the problem of unit root ensure that all the variables used in a regression are stationary by differencing or detrending. Before, before estimating before estimating the output model. Then the danger of reporting regression will be minimized. But if the variables so then minimized. The unit root is used, unit root test is used to check uh, uh, is to check whether the variable is different stationary compared to stationary. Right, so then in economic reason, economic explanation, economic theories often products that variable should be stationary right. So then it is important to check the theory. What is the theory says about? Then keeping this in mind, that's why then you can realize that why that we are using, we can't use the data as it is at using levels. But in our example, so then these two data series, three data series, uh, you will all our data series are uh, stationary at levels. So then if that data series are stationary at levels, so then we can't use the normal regression analysis to test. We can't use t-test to test the hypothesis. So then when that there is a co-integration, we need to test the co-integration. So then our topic is then test in the co-integration. Test of co-integration. Right, so then that means when after testing unit root, then next step is test the co-integration. Right, so then if we are doing that co-integration test, if the variables are integrated of the same order, we can apply the Johansson maximum likelihood method of co-integration to obtain a number of co-integration vectors. Since in our example, since we have two variables, for example, variables GDP and export. So then assume that these two variables are integrated of the same order. Then we can apply co-integration test. Right, after these variables are co-integrated, so then after testing this, so then if variables are co-integrated, it means that they move together in the long run. That means these two variables have a long run relationship. Right, if the variables, if there is a long run relationship, or that they are co-integrated, we can specify by the error correction correction model and estimate the model using standard method of method and diagnostic test. But co-integration indicates that there is a causality exists between the variable in the two series, but it fails to show us the direct direction. What is the direction of the causal relationship? Then, to test the causal relationship, Engel and Granger suggested that if variables are co-integrated, there is the unidirectional or bidirectional Granger causality between these variables. Right, so then what we need to do after now we have tested the unit root. Then I clearly explain why we are that test in unit roots. So then what is stationary mean, what is non-stationary mean? Almost that time series data. So then in your project in the business report, all the that research papers, I saw that most of the data are time series. In the most of the data are time series means all these data, if you graph these data, you can see the trend. So then you need to detrend it, right? You need to convert the data to the stationary process. When if you analyze the non-stationary data by using normal regression analysis, so then your results are not realistic. These are that nonsense, or you do not get the right sign, incorrect, unrealistic relationships, and then not realistic relationships, so then it shows the unrealistic relationships. So then that's why we need to convert the data to the stationary process. When stationary process, after that you need to test whether there is a load run relationship or not by using co-integration test. If the co-integration test shows the load run relationship, but uh, but it failed to show the direct of whether positive relationship or whether it is the negative, the direction of the causal relationship, positive or negative, but it didn't mention. So then to test the causal relationship, there is another test for the Engel and Granger uh, causal relationship test. So then next week, let's discuss the co-integration and the causal relationship in Engel and Granger test. Again, you know that unit root. Right, so then our next topic is next week, and doing again unit root, co-integration test, and Engel and Granger test. Right, then thank you. So then we practice by using the data set. First, you know that what you need to do is graph the data set, and then see whether series are stationary or not. After that, check by the formal test by using the augmented Dickey-Fuller test whether series are stationary or not. Right, that is, you know, that in the time series analysis, it is the first initial step of data analysis. After, you know, that initial steps, then we move to the next step is co-integration and Engel Granger test. Okay, then thank you. Right, we practice for by using these three data series. If you have your own data set also, you can practice. So then I'll give, you know, that the assignment related to the time series data analysis for testing uh, unit root, co-integration, and Engel Granger, and then after that is vector error correction model. Right, so then this is, you know, that if you have a time series data, this is the initial first step of your data analysis.